Hello friends, welcome to our channel DevOps Kaksha. Today we are going to make a serverless web application using AWS Cloud Services, Python and JavaScript, and with almost zero investment. Even if you do not have any idea of these languages or cloud, you can still make this application. Just bear with me till the end of this video. Serverless means no physical server or cloud instance required for our web application. So it is very cost efficient and in high demand these days. Have a look at these job advertisements for your reference. Before starting the application, there are some prerequisites. And the first one is downloading all the code related to our web application from the mentioned Git repo. And the second is making an AWS cloud account. It is free of cost. And if you have already an AWS account, you can skip this step. And the third one is updating an variable value in script.js file with your own API gateway URL. Now let's understand the architecture of this web application. This application will be a to-do list management service. And there will be four major components of this web application. The first one will be Amazon S3, which we are going to use for the front-end hosting. It is the easiest way of deploying a website. And the second component will be Amazon API Gateway. It is the communicator between the user and the backend service. It takes requests from frontend and map them in an backend understandable format. And the third component will be Lambda function. It is nothing but a Python program for backend processing. The fun of using Lambda function is that it is serverless compute. Means you do not have to provision any server to execute its code. It will be auto-invoked whenever there is a new request from API gateway. But Lambda require permissions to access other AWS services. And in AWS, we need to define an IAM role for providing permissions. And fourth and the last component would be DynamoDB, in which we are going to store our to-do items. I hope you have a basic idea of our web application components now. So without any delay, let's start building our application. Here we are in our browser, signing into our AWS Cloud account. Here we are going to create our components in reverse order. So first of all, we will create a DynamoDB table with the name, tasks and partition key task ID. Rest of the settings we will keep as it is and create table. Once it is created, we will add our first to-do item in it. As DynamoDB is schemaless DB, so we do not have to define any structure of table before entering items. Here I am adding 4 attributes to store data related to any to-do item. Task ID, task name, task description, and status. Our table with the to-do item is ready now. So first component of our to-do web application is ready now. Let's create a Lambda function to access this DynamoDB table and an IAM role to give it required permissions. Here we are in IAM service creating a role. As this will be consumed by Lambda, so select Lambda service here and then next. Now we have to select permissions for our Lambda, like it is going to communicate with API gateway, DynamoDB, and some basic permissions for execution and debugging purpose. Let's name it as Serverless Web Service Role and review it before creation. Principal service to consume this role is Lambda. All three required permissions are also added. Everything seems good. So here is our IAM role created. Next, let's create a Lambda function, which is nothing but a Python program to perform some actions on this DynamoDB. Let's name it as a task manager function and select Python as its interpreter. And yes, replace the default execution role with the one we just created. And create function. It will generate a basic hello from Lambda Python code for us. Let's replace it with the one shared in our Git repo. Open to-do Lambda function Python file. In this I have imported Boto3 library, which is AWS SDK for Python. In simple language, it is used for accessing any AWS service in Python, like DynamoDB in our case. This Lambda handler function is the entry point of any Lambda function. It will check for incoming HTTP requests and route it to respective operations. Like for GET request, GET task function will execute. Here I am taking task ID from query string and checking if its value is all. Then scan all table items and return it. If task ID is not mentioned in request, then return an error. Else take task ID and return task name, status, etc. of that particular to-do item. Similarly, you can check other operation handler functions here. Let's copy and replace it with the basic Lambda code provided. And deploy it. Now, before moving to the third component of our project, I always like to check our Lambda function by sending an HTTP request and checking if it is behaving as intended or not. We can create a test event and send an query string to test our function. Let's name it as test and select predefined template of API gateway. Now change HTTP method to get and mention task ID in query string. Because in our getTask function, we are checking for query string parameter here. Let's save and test. Yes, it successfully retrieved to-do item details from DB. So it is working fine. Let's create a REST API to interact with Lambda function now. Open API gateway. And name our REST API as task manager API and create. Now let's add methods in it. Here method type will be get and attach it to Lambda function we just created. And query string, here we have to mention task ID as required field for get method. And create method. As you can see, get method request flow here. Request will be handled by task manager Lambda function. But one thing left here, we have to define mapping template to convert the request into a Lambda understandable format. Here content type will be application/JSON, and mapping templates for each method I have uploaded in Git repo under API Gateway directory. Let's copy and paste it in template body. Now I will pause video and create rest of the method similarly. Next, enable CORS for all the methods. It is a security feature enforced by mostly browsers these days. Save it. And deploy our API with the name say prod. Let's copy its URL and test it using Postman application. You can also test using curl command if you do not have Postman application. Click on plus sign to test any method. Paste our URL, and for passing query string append /? task ID equals to 101 and send. The same item is retrieved from DB. Similarly, we can check other methods as well. Is not it fun? We are just sending API request and cloud is managing everything for us like DB, all infra, and with almost zero cost. So our API gateway is communicating well with Lambda and retrieving data from DB. Now let's move to our fourth component, which is the front end of this application, and provide controls to user to manage their to-do list. But before that, we have to update the API URL in our code. Hope you remember third prerequisite. Now create bucket in Amazon S3 and name it as to do bucket list. No caps allowed here. And uncheck this box. Make this bucket publicly accessible. And create it. Our bucket is created, but now to enable it to host a website, go to properties and enable it. Mention index.html as start point of our website here. And save. Website URL is available to use now. Next we have to attach a bucket policy to give it permissions. I have added this bucket policy in Git repo. Here principal star means anyone can get this bucket objects. Copy and paste it in bucket policy. And don't forget to change your bucket name here. Save. And copy our website URL and upload website code. Go to objects and click on upload. Add files and select all files from front end folder. And upload. Once uploaded, open a new tab in your browser. Paste the URL. If you have followed every step till now, you should see this UI loaded. Get all tasks to retrieve all the to-do items, or add a new task. Enter any task ID, say 103. Enter its description. Start from today's evening. I'm pretty sure it's going to be in pending state forever. So it's updated. We can also delete a task like this. Alright, with that we came to the end of this video. Comment down if you have any feedback or questions. I will be replying in the comments. To support my channel and see more such content, please subscribe to my channel and give this video a thumbs up. Bye bye, happy learning.